Each type we will study the function, okay? And then we will, what is differential white count, white blood cell count, is it's also being asked, prescribed by the doctor if a patient comes, because counting the white blood cells can determine what type of disease, a specific disease, so that the doctor can have a specific diagnosis, okay? And then complete blood count, phagocytosis, and antibody production, because leukocytes are immune cells. They're the ones that prevent us from having disease. They fight bacteria, they kill virus, they kill parasites. So that if our immune cells are very good, so we are at least resistant to diseases. We are more, we have the mechanism so that disease will be prevented from coming to our body. But when you say, oh, your immune system is very low, somehow, yeah, this statement is correct. When you say you always get sick because your immune system is not good or very low, so it means about leukocytes, because they're the ones responsible for protecting us, okay? And then of course the platelets count here. Okay, leukocytes are white blood cells. They are larger than erythrocytes and have nuclei, okay? Although they do not also try to, they also don't try to propagate out. Yes, they have some sort of clonal process when they are exposed to some pathogens. When you say pathogens, these are the molecules that harm your body. So example there will be dust, pollen, bacteria, virus, fungi, parasites, poison, toxins, and so on and so forth. Yeah. So if you look here, this is the process where our blood cells are formed from the stem cell. So again, you see the CFU, CFU for erythrocyte, CFU for megakaryocyte. Megakaryocyte is the baby of platelet. And then CFU for leukocytes, which is granulocytes. So if you look into here, this is not in your book. I place it here. If you look here, you see it's Tortora. So your book is Ammerman. Your Ammerman is not good.
So why you suggest us buy that then?
I put them together, easy to memorize, easy to visually look into everything. Your Ammerman is divided here, divided here, divided here. You have to put them together, paste, so you can have all. In this slide, everything is here. Okay. So, and if you look here, so you have CFU, erythrocyte, CFU, megakaryocyte, which is your platelet, and then you have two kinds of stem cells. You don't concentrate. You're always the ones that asking something. Study very well. Here you learn a lot. Listen to me. Okay. So, because you drift away. I see your faces who's drifting away. Yeah. Okay. Myeloid stem cells, two types of stem cells. Remember this. This is a classic question. Myeloid stem cells and lymphoid stem cells. Look, what are those mature cells that come from myeloid? And look at those mature cells that come from lymphoid. So lymphoid means lymphocytes, right? So easy to understand. So if you look here, okay, so these will become here. Look here on this side here, okay? So this becomes the red blood cell. This becomes a platelet. This becomes the eosinophil, basophil, and neutrophil. Now it's a new terminology, right? These are white blood cells that are classified as granulocytes. So this is great. Okay? So leukocytes are classified into three. Classified into two. Granulocytes, because they have granules in the cytoplasm. Agranulocyte, because there's no granule. So there are only three granulocytes. Eosinophil, basophil, neutrophil. And then two more without granules, which is monocyte and lymphocytes. Now, if you look at the stem cell, okay, everything comes from myeloid. Even the monocyte, which is agranulocyte, okay? Everything there. However, the leukocytes come from the lymphoid. Yes. These are leukocytes. So leukocytes again, which is the lymphocyte, are divided into many forms. T cell, have you heard T cell? You've heard B cells, which is produced in the body, right? And you've heard NK cells, natural killer cells. So these are the ones. Okay, repeat. Granulocytes of leukocytes, eosinophil, basophil, neutrophil. A granulocyte of leukocytes, monocyte, and lymphocyte. Lymphocytes is divided into T, B, and NK. You see these? A granulocytes. This is granulocytes. Okay? Okay. So that you have to memorize. Okay? Okay, so leukocytes usually don't function within the blood because they go out of the blood, of the blood cells. They go somehow into the lymph nodes. They circulate. They are going around and looking for bacteria or virus, and they actually kill phagocyte. That's why white blood cells are, some of them are macrophage. So macrophage is the one that like eat like Pac-Man. When they look, when they see, they eat, destroy it. Okay, so that's what it is. Okay, now if you see the structure, the differences, neutrophil has 3 or more lobes in the nucleus. Eosinophil has only 2 bilobed and beautiful red granules in the cytoplasm. Sometimes we call this polymorphonuclear cells. Okay, and then basophils purple. You do not see much the nucleus because the cytoplasm is very strong colored purple. So, and they have their own function. Okay, 1. Neutrophil function, bacterial infection. So doctor will go differential count, very high neutrophil, you have bacterial infection. Maybe you have fever as well. Okay, eosinophil, wow, if you have roundworm, you know roundworm? Parasite. So the eosinophils will go up. Okay, and also allergic reaction. And then basophil, usually allergic reaction. Okay, got it? Okay, so remember, I don't write everything, so up to you to know it. Okay, let's go to the lymphocytes and monocytes. Both of them are agranulocyte. What's the characteristic? So the lymphocyte has round nucleus. And monocyte has like a horseshoe or kidney-shaped nucleus. And monocyte is the biggest among all. The most number of leukocytes is neutrophil. Take note of that, yes. Again, it's not written out in your slides, okay? Okay, again, granulocyte contains granules in the cytoplasm. Some of them might multilobe or not. So we have neutrophils, eosinophils, and basophil. What is the function of neutrophil? What's the function of eosinophil? What's the function of basophil? I just said it a minute ago. Are you already sleeping? Okay, what is the roundworm? Eosinophil, correct. If you have lots of bacteria,
Now, did you go?
neutrophil. So if you have allergic reaction, see? Hey, don't sleep. Right, okay. Okay, so that's neutrophils, polynuclear cells. So we know that already. Chemotaxis, we know this. It's in the blood with this granule kill bacteria. That's your neutrophil. It's clear. Eosinophil, bilobed, you have that. And then parasitic. Worms. Okay? So you can remember, so you have to memorize. And then basophil. Yes. With that, so for information, antihistamine, histamine. So that's correct, yes. And then you have your leukocytes and granulocytes, lymphocytes and monocytes. So you know that lymphocytes, 20%, 25% are leukocytes. So two basic types of lymphocytes, B cells and T cells. And of course, the one that is already extra that we say is NK cells or natural killer cells. So it produces, the B produces antibodies. So T cells can transform to cytotoxic, usually with the viral thing, yeah, here. And then specific immune response is in this too. Specific immune response is when you become sick, and then your barrier of your immune system cannot hold it, and then you have the specific immune response. Bacteria go inside your cell, it will be killed, or bacteria in the tissue of your body, outside of the cell, it also will be killed. So the B cells strike outside the cell, the T cells strike inside of the cell. We call this a specific immune responses, which we will study when we go to, I think, lecture 36 or 35, the last chapter. Okay, now, lymphocytes, the B and the T, so remember these because they have this different pathway. So the B mature in the bone marrow. It doesn't go away. Like just when it's born there, it matures there in the bone marrow. So they are very, very much active in producing antibodies. Remember, T cells don't produce antibodies, only this, okay? Antibodies bind with antigen. I put it on a different table so that you can understand better. Okay, and T cells travel after they are born in the bone marrow. They travel even if they're young. They go to the thymus. They are stored there. They are mature. Thymus gland. Okay, not the B cells. The B cell can go there to store, but it will not mature. Okay, so T cells do not produce antibodies. Take note of that. Okay? Okay, so more B cells, each population visits lymphocytes secrete antibodies, very unique because each antibody will kill one particular or a specific pathogen. Yes. Yeah, one antibody, one disease, one antibody, one disease. It's very, very specific. And of course, the T lymphocytes, the population is very specific as well. Okay? Okay, let's go to monocyte. This is my favorite monocyte because they're the ones that are really on the primary line of defense. They are just scattered all over the body, maybe in your tongue, in your mouth, maybe in your vagina, maybe in your skin, everywhere. And then when they say bacteria, they just eat automatically. Yeah. So you have to be appreciative of the monocyte. Okay? Okay. So see, in the tissues they mature into active phagocytes called macrophage. So when they see them, yes, die, ingest. Very good, huh? Activate other parts of the immune system, display phagocytized antigen. So they are the primary part of your immune system. Okay. Next again is how the leukocytes are formed. So the general term to produce blood cells is hematopoiesis, right? Now, we have leukopoiesis specific for leukocytes production. Still in the bone marrow, of course, yes. We know that. So again, repeat the slide. So these are from here is your leukopoiesis. Okay, 1, 2, 3 agranulocytes, and 1 and 2 agranulocytes. Granulocytes. And this is the barrier. So this is your platelet, this is your red blood cells. And if you look again, all of these up to monocyte will come from myeloid stem cell, and lymphocytes come from lymphoid stem cell. And all of these here, the slides are all babies. Okay? And all of these here are all mature cells. Right? Good, good. Okay. If I asked you, what's megakaryocyte to become an adult? What's megakaryocyte? Hurry, hurry, look, look,
No,
look.
no, no.
Look, 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 look. Red, beautiful, good. And then reticulocyte. It's a baby. It's a boy or girl. It becomes red blood cell. Very good. So, what about monoblast? Becomes what? What about lymphoblast? Becomes T3 or TOV or intake. Very good. Yes. See, easy, right? Okay. Then you have all those nuclei formation, so you can differentiate. If I cover these, or I cover that, would you know if it's eosinophil, neutrophil, basophil, lymphocyte,
Maybe
monocyte?
next week.
You want next week exam?
No.
No.
Next week.
After
no.
reading.
Yes.
Okay. I will describe that in the exam, then you tell me the answer. Okay, let's go to the platelet. So platelet. Platelet's easy. Its function is blood clotting. Okay, so that's blood clotting. So cell fragments, a plasma membrane. It doesn't have nuclei as well, and it looks funny. It doesn't look like red blood cells. It looks like just specks in your blood. Look, looks like that. So like specks, small. So it has granules, it has also clotting factors, it has enzymes, few mitochondria, and few glycogen deposits. So it has also like a cytoskeleton, like a typical cell, but not really a typical cell with a nucleus with all those organelles. So we go to the formation again, megakaryoblast, then megakaryocytes, and then platelet. Very good. 25. Okay, so hemostasis means blood clotting, to stop the blood. To stop the bleeding. That's hemostasis. To stop the bleeding. And then of course the blood typing. So the blood typing, we inherit that from our parents. So this is genetic. Hey, you're the ones noisy. Listen, listen.